So today we're just gonna do homework 7. Um, 7. Right. So the data is open here already, and for the first question, A, it asks what's the hypothesis for the test, and for the H0 is gonna be. It's gonna be the IQP for IQP raw when the area 1 equal to IQP raw area 2 equal to IQP raw area 3. So this is H0. And, and what is the alternative? It is at least one of the IQP raw is different, right? And then let's go to the B. So how many groups are being compared in the problem? Let's see the data. So we want to compare the IQP uh, IQP raw, right? This is the number we want. This is numeric. We want to compare this with what? With itself. But in these groups, area is a group variable. There are 1, 2, 3. There are 3. So here are 3 groups, right? 3 groups here. And find the summary data. So how can we do the summary data? We do tab stat IQP raw and then by area. So okay, let's do this first and see. Oh, this only gives me mean. I don't want this. I want more. How about this? Statistics. I want number, I want mean, and variable, minimum, median, and then max. So okay, here this is everything we want, and or you can type in more, and then here is the procedure is indicated with the procedure. Okay, so not to use that. Okay, so how we want to do this graphically? Right. So it's gonna be like graph box IQP raw, and then over this. Okay, let's wait. Okay, here. So this is the box plot. So I want to say something else here. So this we are using over here. So that's in the same graph, right? And if you are using, I think if you're using by, it's probably gonna be separate. Yes, it's gonna be 3 separate graphs. So let's use over here. Over here. Awesome. So, well, let's just talk about this. You see this is the median, right? This line is kind of at the same area, and the variance, like how this kind of spread, is kind of, this and this and this is kind of similar, and this and this and this is kind of similar. So you can see all of them. I would say for my bare eye, I would say the mean is kind of similar. I would say, and the variance kind of similar, just from this graph. And so now, for the question C, are the variance of the mean close enough to use the procedure that's indicated by this? From this, I would say the variance is, but we still need to test for that. How can we test for it? That's this test is included in the ANOVA test. So let's do. But for C, I would just say it looks kind of same. Kind of same. Then let's do D. Is test the hypothesis. Okay, so this is gonna be test the A, right? So it's gonna be one-way IQP raw area. And so, see, this is the ANOVA test. This is the p-value for the ANOVA test, and this is the p-value for equivariance. So this number 0.056 answers the question in C, and this number 0.3099 answers the question for F or and D. Okay, so what's the p-value for the test? For D, we're gonna say this is the p-value for the test. And for the C, you can say just refer to the result from D. The p-value for the equivariance is this much, so we do not reject the equivariance one. And then for E, what are the assumptions? So first, let's say there are 4 assumptions. First one, it should be K independent population. Populations. And then for E2, it should be random samples from each population. Okay. And then for E3, so the third assumption, and should be large samples or normal population. If this assumption is not met, we could still do this kind of comparison. D has already did this in her slide, so you can refer back to that one. And then for next one, for E4, it is equal population variance. So this is kind of what we did for number 3. No, C. Question C, right? Yes. So this is what's for E. And then for F, state your. So for question F, what is your decision, and what's your decision? So for this one, I would say, so the decision would be we do not reject it, and the conclusion would say we do not have enough confidence to say it is different. And then for G, well, you see, G is if indicated you do post hoc, right? But this one, because we would say it's similar, so we do not reject it. So we don't have to do a post hoc test. We only do a post hoc. I'm sorry, I'm still in the first floor lounge, so it's kind of loud. But everything needed, I put it on the screen already. But here, so we don't need to do a post hoc test. But here, just for the practice for the question, let's do it just to prove that there is no difference. So there should be one-way IQP law this area, and then Roni, Shefei. So as you can see, this is small, and this is, so all of this is greater than 0.05, right? So we'll say there's nothing different. And so for H, okay, so what's something if it is real life, we might need to consider is when we're doing this test, the Bartlett's test, this p-value is 0.056. It's really close to 0.05. When it's smaller than 0.05, we reject it. But this one is just around 0.05. So we cannot say, we are going to reject it, but it's like really borderline rejected. We do not reject it. It's like a really borderline not rejected. So this was considering, maybe the variance not not equal. So you could say something like this. Okay.